Hey everybody, this is Larry. This is day 12 of the April Leetcode Daily Challenge. Hit the like button, hit the subscribe button. Join me on Discord, let me know what you think about today's poem. Today's poem is Game of Life. Okay. I guess Game of Life is pretty standard, so let's take a while to see how everyone else is doing. Yeah, so this is Monday or Tuesday, wherever you are. Hope y'all having a great week. Everything's going okay. I am going to I don't know. Let me know y'all been what movies y'all have been watching. I've been going on watching a lot of movies lately. Let me know in the comments or Discord. There's a lot of cool, smart people hanging out on Discord. Need to create something. Also, if you're in New York, let me know if on Discord because I think we're trying to get some like hangout or whatever going around. We'll see what that goes. Anyway, today's poem is Game of Life. So we know what Game of Life is, or as I do. If you don't, then I guess that's what this is reading. And I guess it's good that they don't, um, you know, uh, uh, whatever. But let's look at the follow-ups, just because this is pretty straightforward. Could you solve it in place? Remember, the board needs to be updated simultaneously. You can update some cells first and update. Okay. In this question to the array, in principle, the board is infinite. What would cause problems when the act? Oh, I guess this is just talking about it. Yeah, I mean, I think you can always do something like repeat doubling is always an option. I think the thing is that you're trying to do the math on the repeat doubling, and of course, if you do the math on the repeat doubling, which is actually comes up in hash tables and stuff like this, if you ever study it, then you'll know that maybe repeat doubling isn't but basically once you get to some fill factor, in this case, you could wait until it hits the border, then you can double it, right? In that case, it's going to be amortized constant just because you can do the math the same way you do it with hash tables. So I think that problem, we could talk about that if y'all like, but that's basically the idea that I would have there. Though in the 2 dimension, maybe that's a little bit more tricky, but I don't imagine so, because I think you could treat the dimensions independently in either case in terms of that. Of course, you can also treat maybe sparse arrays or a sparse matrix and play around with that depending on how it goes. I don't. Yeah, it may be a little bit tricky. The second part, which I guess we'll try to do now, is to in place because this is relatively straightforward. I don't think this will be a medium anymore, to be honest, just because this problem is very old. But that said, not to say that in an interview it will still be okay. But but yeah. So how would you do this in place? I actually don't know. Let's see. I think it's so. Uh, there is a cheating way of doing it in place, but I don't like it, which is just you see that these things are ints, so you kind of use like the upper bit or maybe use like another bit, right, of that int, because an int could fit 32 bits or whatever. So you could play around with that idea, and that'll technically work. So that's fine, maybe. But I feel like that's almost cheating and not in the spirit of things. Because maybe what if these are booleans, right? So then can you do that in that way? And I think in that case, I would have to look at the rules and kind of think about it, which I haven't done yet, to be honest. I hope it's not the upper bit thing, because that's like I consider almost cheating, or it's like it's not that interesting, right? Like you just use extra space, just embed it into the thing or something, right? Okay, so the rule is fewer than 2 is dead. So I guess the way that I would think about solving this, if you have to update this simultaneously, so to speak, is that you try to, even though it is simultaneous, you try to exploit the rules in a way such that it is not simultaneous, right? Maybe it doesn't make sense for the game of life, but there are rules where, okay, you maybe change it to 0 because no matter what happens, the change to 0 will always be true, etc., right? So yeah, so I think I would see it that way, and then see if you could figure out some ordering in which you can do it. I don't know that I remember. My experience of Game of Life is that I don't think that that's a thing, but I could be wrong here. Let me see. I do have to go watch a movie, so that's why I'm asking. I'm watching, in case you're wondering at home. Everywhere Everything Everywhere All at Once, something like that. It got great reviews. I'm gonna try to catch the night show. Um, but yeah, I don't know. Hmm. I mean, yeah, I don't know if I know one that isn't like quote unquote cheating. And if we are going to cheat, I don't feel like, like if you're gonna do some kind of hacky things like that, then I always opt for making more beautiful code unless you um need to optimize, right? Like there's no you shouldn't prematurely optimize, because if you like if you like maybe if you're doing like embedded systems, or you're putting it in your handheld, which at least way back when in the day, like maybe that's a thing that you have to consider, like space efficiency, like you're programming for Nintendo, like 20 years ago or something, like the NES, maybe more now, 20 years ago even. The PlayStation's already out, but I can't do math all the time, so yeah. I don't know. I don't think that there is. I would be honestly a little bit kind of surprised if you can, just because, and some of this is arrogance in the sense that if there's a way to do that, I would have known already. In the sense that I have, and this is maybe applied to your career as well, is that when you have oh, my alarm clock is ringing. Hang on. I had to tell my Alexa to oops, now it got triggered again, to turn off my alarm, because it just kind of it was to wake me up in case I was taking a nap too long. But in any case, yeah, so that's what experience means, right? Is that you know you you have seen it enough, and I've seen the Game of Life, a lot of variations, a lot of time. It comes up on AOC, the Advent of Code. It comes up a lot of. It is a very finite automata type thing, where everyone is just very interested in this problem, and there are a lot of what you might call it. There are a lot of easy computer sciencey problems to explore with just like simple rule set, right? Which is why it draws a lot of people to it. And you should read the Wikipedia article by the mathematician Conway. He passed away 2 years ago, I want to say. That was kind of sad, obviously, but so yeah, so definitely, like, to that sense, and I probably have been very interested in it at some point in the past, especially this idea of if you really read deeply into it, and I encourage people who are interested to do so. There's also like this stuff with respect to Wolfram's A New Kind of Mathematics, I think is the book. I'm calling it off my head, so if I miss name some books or whatever, leave a comment or Google or whatever. But yeah, so definitely it's just very interesting. And my point here is that if I have known it, maybe I would have seen it. I mean, I'm not 100% certain. I have a lot of gaps in my knowledge, like the Z algorithm from the other day. But yeah, but that's what I believe. So with all that said, that's just my long way of rationalizing and explaining to you that I am just going to do it with the extra bit, the cheating bit. And then, well, I'm going to do it in another way, right? And then I'm going to do it the extra space way, and then I'm going to rewrite it so that you can see what it looks like when you have the cheating bit, as you call it. I call it that, but it's not. Maybe it's fine. I don't know. Okay, let's get it started. Let's just go. How many iterations do they want? I actually missed that part. Is it just one state? Okay, so it's just the next state. Okay, so yeah, so you just do next board is equal to well, let's set it up. R is equal to length of board. C is length for board of 0. Just making sure that it cannot be 0. So okay, otherwise you get a out of bounds. Okay, so then here we set it to force times C for right. So now we're just saying by C board. So now we go for X in range of R, for Y in range of C. We go maybe do something like you only care about live neighbors in these rows. So maybe we do like a if count count of xy, or maybe just c is your count of xy. So then you can do and then you can do all sorts of permutation, meaning if board sub c. I don't like this 1-0 thing, but it is what it is. So because I think that's I don't know. Okay. Oops. Board of xy. If this is let's see, fewer than 2. Oh, this is 1. Okay. If this is 1, then, I mean, this is just really going through the cases, right? If c is fewer than 2, next board xy is equal to false, right? Yeah. Else if c with is between 2 and 3, then next board xy is equal to true, and then else. I mean, I also, you know, just want to be clear. I know that I can rewrite this if statement in an easier way or shorter way, but I want to be as explicit as possible so that when you make a mistake, you don't have to just debug your logic. You can just look at the code and look at how it translates to the rules that they give you, right? So that's basically the idea. Okay. Otherwise, okay. So that means that this is dead. If c is equal to 3, next board is equal to true. Else next board stays dead, right? And then now at the very end, we copy it back over, right? Next. And I know you can do some stuff, but yeah. But I like to be explicit for this particular example, just for the straight. Oh, there's no return, but of course we have to write this count function, which we haven't done yet. Yeah. Yeah. Let's see, right? Yeah, for dx in range of from -1 to 1, of course it's 1 plus 1 because it's exclusive. I always find that a little bit awkward, but I'm going to writing it out so that you can kind of see what I mean. But yeah, if dx is equal to 0 and dy is equal to 0, we continue. I sometimes write this differently, but today I'm just going to write it this way. So yeah. I guess one minor optimization. I usually write it together, but I guess I can do it here. And also that if we have to make sure that this is inbound. So if not this, continue. I might have to need parentheses because I'm not sure. And then yeah, just for symmetry reasons, do the same thing here. And then if okay, so total is 0, 0. If board of nx and y is equal to 1, right? And then return total. So this should be okay. I hope this is okay because otherwise it's embarrassing. But I mean the idea should be okay. It's just that I might have typos and stuff like that, right? Yeah, so that looks good. Let's give it a submit. Apparently I did it a couple of years ago, so that looks good, right? So this is going to be linear time, linear space, because we look at each cell maybe well, let's say 10 times from left up, down, left, right, and stuff like that. And yeah, and that should be good, right? Like, I mean, obviously, because we just got accepted. So the way to do it in place, and I'm not a fan of this. Maybe we can kind of see if there's any clever way to do it in place. But the way that I would do it is just by, instead of having this next board, okay, let's just say, this is so awkward. Let's just say so now you can think about a binary bit as a number of base 2. So then we only care about the current board contains 1 bit and the least significant bit, and then 1 more in the second one, and then we can store the next place here, and then afterwards move it to the right. So that's basically what we're going to do. We just have to make some changes here. We have to say if this I know that you can use a bitwise operation here for those smarty pants who are a little advanced, but whoops, almost had a typo there. But I wanted to make sure that, I just want to mod 2 so that it's clearer. And here we also mod 2. And yeah, and that should be maybe good for now, at least this part. But here now we have to set up the next board, right? So yeah, let's just say maybe next space is equal to force, and then now we can just convert it here. And this is where I talked about a little bit about don't repeat yourself and stuff like this. That's where this could be helpful by having fewer if statements, but that's okay. We're going for the most direct code. So then now, before we might have written something like this, right? And that'll be fine. But of course, this doesn't exist anymore. So what we want to do is store it in the upper bits, right? So then here, oh no, not that. Is equal to we'll be we'll keep into theme with being as explicit as possible, but yeah, so then we add 2 if this is the case, right? And then at the very end, yeah, we can just do if if this divided by 2 is equal to 1. Again, I'm just being very explicit, otherwise it's equal to 0. Let's try that again. Again, you can use bitwise operations. I'm trying to be as generic as well, not as generic, but I think as clear as I can to maybe possible newcomers and stuff like that. So let's give it submit. Should be the same, a little bit faster apparently, but yeah, that's pretty much what I have. Again, this is gonna be linear space and linear time. I don't know. Like I said, this is a little bit awkward. So, but you can do it if you like, is my point. What did I do in the past? Why is it faster? Okay, I mean, guess I did the same thing, pretty much. I didn't want for loop, and I think the function calls probably make it slower, but not by that much. I don't care. But yeah, that's all I have for today. Game of life. Yeah, stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.